Alright, hi everyone. Welcome to a basic class on loops, functions, and callbacks in JavaScript. This class is specifically for people who were slightly overwhelmed in our 1.2 class. We're going to discuss how loops actually work. We're going to go slightly into the depths of why you need functions and the syntax of functions. And at the very end, I'll finally introduce again callbacks. Callbacks was something that was slightly overwhelming for everyone, rightfully so, I think. So we'll try to introduce a more intuition-based approach to callbacks. If you already know loops and functions very well, then feel free to skip directly to callbacks. It should be at the very end of this video. With that, let's get right into it. Let's start with understanding what are loops, why do you need them, and can you actually survive without loops? Let's look at a problem statement. The problem statement says, calculate the sum from 0 to 100. Can you write code for this? This is the dumb way of writing code for this. Let answer equal to 1 plus 2 plus 3 and so on and so forth. Let's say we're going to restrict ourselves just to 50. This is how I can write the code that calculates the sum from 1 to 50. If I log this at the very end and if I run this code, I will actually see the right output printed at the end of my screen. But is this the right approach? What are the flaws in this approach? Flaw number 1, it is very verbose. I see too much text here. Flaw number 2, if I change the number from 50 to 500, you're going to have to write a lot of code to achieve this. You don't have that time as a developer, and as your application grows to a million billion users, it's very hard to keep writing these things again and again. This is where loops come into the picture. When you know you want to do some repeated logic again and again over some values is when you should use loops. Harkirat, you say repeated logic. What is the repeated logic here? If you look at it, what am I doing? I'm saying start with 1 and then plus 2 and then plus 3 and then plus 4 and then plus 5. This is the repeated logic. The value is changing, but the logic is the same. I'm adding a certain value again and again. Whenever you have use cases like these, you should use loops to iterate over these numbers and rerun this logic again and again. Let's see what that looks like syntactically. This is the solution for our problem. It says let answer equal to 0. So this is the initialization of an answer answer variable. Then we say for let I equal to 0, I less than equal to 50, I plus plus, answer equal to answer plus I. This, if you notice, looks like the repeated logic that I talked about. In the last slide I said plus 4, plus 5, plus 6. This is repeated logic, but the value is different, but the logic is the same. Similarly, if you look inside the loop, ignoring the syntax at the moment, inside the loop I say answer equal to answer plus I. I have somehow just written one line of code that has that repeated logic, and I've been able to achieve the same thing that this slide was achieving. Question is, how does a for loop actually work? How did this code base lead to the same output as this code base? Let's try to understand that next. How exactly does a for loop work? What are these 3 sections separated via semicolons? What do they do and how do they achieve the same output as the code like this? Cool. Let's try to visualize how would code run when you've written the code like this. What line runs first, what line runs after it, and how we arrive at our answer at the very end. If you run this code in the terminal, the first line that will run is this line, let answer equal to 0. So answer gets initialized with the value of 0. Then the next line that would run is ideally line 4. But when you write a for loop, the whole line does not immediately run. First, this section runs. What is this section? It's called the initiation of the for loop. It is used for initializing some variables for your specific for loop. In our case, we initialize a new variable called I with the value of 1. This is very similar to me initializing let answer equal to 0. Why do I initialize I and why do I initialize it with 1? The answer is we want to start from 1 and then we want to go to 2, 3, 4, 5, 6, so on and so forth, which is why I initialize I with 1, and that's my initiation step. That is the first thing that runs after this line runs. Once this has completed and I has the value of 1, which is what you see on the right, then this section runs. This section is called the comparator section. What this section does is, okay, bhai, if this condition is true, then I will run this logic. If this condition is false, then I will break out of the loop. We keep saying loops. I said this is a for loop, which means it is supposed to loop over some logic. What is that logic? This is that logic. How does the for loop know when to keep looping and when to break from it? The answer is this section right here. Anytime this condition is met, then it will run inside. If this condition is not met, it will break out of the for loop, which means line 8 would run. Cool. If we start from the top, what were the 3 steps? We started from here. Then we went to the initiation step. Then we went to the step of checking, okay, is I less than equal to 50? And is that true? Is 1 less than equal to 50? It is. And so the control reaches here. And what does this logic say? It says answer equal to answer plus I. So what gets added to 0? 1, which is why the final value of answer becomes 1. These 4 steps that have been taken is similar to this 1 plus right here. The first step has been done. Now as the loop proceeds, the rest of the steps will get added. But at least the first step is done in just 1, 2, 3, 4. When all of this happens, answer becomes 1. What happens next is something new. We have discussed this part, we have discussed this part, we have discussed this part. This we have ignored. After a loop finishes, it does not exit out of the for loop. It goes to this section right here, which is what happens after the body of the for loop has been completed. After all the logic runs here, control reaches here. At this stage, you do something extra. You add something to your variables. Usually you will see I++ here, which basically means you're increasing the value of I by 1. When you do that, what would I become? I becomes 2 here. Now, same things happen again and again. After you don't re-initialize. This step is only done once. But these 3 steps will now happen in a loop. We will increase the value of I, it will become 2. We will check, okay, is 2 less than equal to 50? It is. So next the control will reach here and 2 will get added to answer, which means now I have done the first 2 steps. I have done 1 plus I have done 2. Next again, the control will reach here. I will become 3. We will check whether or not I is less than equal to 50. Since it is, we will add 3 to the answer, and so on and so forth. This will keep happening until, so 4, 5, 6, 7, 8, 9, 10, it will keep happening until I becomes 51. When I becomes 51, so we increase it by 1, we check whether or not I is less than equal to 50. Is that true for 51? No. Which is why the loop finally breaks and you log the value of answer. And what is the answer? It's a very big value now because 50 times we have run this loop, 50 times this logic has run, which has added 1, 2, 3, 4, 5 up until 50 to this answer variable. And when you print it at the end, you have your final answer. This is the right way to find the sum from 1 to 50. What was the wrong way? The thing that we saw a few slides ago. Don't write it raw 1 plus 2 plus 3 plus 4. This is the better way of doing it. Why? Because if I tell you, okay, now give me the sum from 1 to 100, all you have to do is change this variable and you will find your final answer. If I say, give me the sum from 1 to 10,000, just change this variable and the value of answer will be right because the loop will run as many times. That is why loops are so powerful and the right way to do logic like this. Anytime you have any repeated logic that needs to run again and again with a slightly changed value in every iteration, you use a loop. For loop is the most popular one. That is the one we are using right now. There are some other ones called the while loop and the do while loop. We will get to them if we need it. This is the most popular one. 99% of the times, this is what you need. Cool. We're done with loops. Let's get into. Before we do that, let's try to visualize this on a website if you want. There is a very famous website that we will be exploring next week as well. This is the link to it. Let me open it in a browser. This website lets you visualize how the code is running. Feel free to ignore this and this. We will discuss this next week. Let me write a simple for loop. For let I equal to 0, I less than 10, I plus plus, answer equal to answer plus I, let answer equal to 0, console.log answer. I have written the same code over here. When I click on save and run, you will see a few things here. Ignore them, but focus on how the control runs here. So if I click on save and run, you will see control reaches here, then control reaches here. This is like actually not the best visualization. It says control reaches here and here. It actually ignores the I++ section. But ideally what is happening is, as you can see, it's running and running and running again and again. Control reaches here, it reaches here. It also reaches this I++. This website is not visualizing it, but this keeps on happening until your condition is met, which eventually it will not be, because after 10 iterations, I will become 11 and it will break out of it. And the final thing will get printed on the screen. Let's wait for a few seconds for it to break as well. I think it will happen after 10 iterations. There you go. It broke. By broke, I mean it broke out of the loop and then this got logged. So if you want to visualize it, feel free to, even though this wasn't the best visualization, it missed the initialization step. It also missed this I++ in every iteration. Cool. All right. I think that's all for loops. Yeah, that is it. Next, we're going to discuss functions. So functions are a language independent concept. They're not really JavaScript specific, but they solve a specific purpose. Let's understand what that purpose is. This is the textbook definition of a function. What is a function? A function in JavaScript is a set of statements that perform a task or calculate a value. It should take some input and return an output where there is some obvious relationship between the input and the output. Too many statements here. Let's try to break it down. A function is a set of statements that perform a task or calculate a value. Basically, a function is an independent set of code that does something inside that specific sort of code. This is very vague. Let me rephrase it. A function is a bunch of lines of code that do some logic, like 3 lines of code, 5 lines of code, but there is something specific about them. It should take some input and return some output. So one specific thing about functions is, okay, they are supposed to take an input. What is an input, Harkirat? Integers, strings, booleans, things like these. It is supposed to take an input, run a few lines of code, do some math logic, something with those inputs, and then return an output. It basically needs 3 steps for it to be called a function: an input, some logic to manipulate the input, and then some output. You can think of it as an independent worker that you have. Worker as in, your house help that you have, that you delegate a task to. Okay, bhaiya, you are going to wash my dishes. So you tell him these are the 5 dishes and you have to wash them with this soap, and then the worker washes them and then finally returns to you, okay, I have washed all the 5 dishes. Similarly, in code, or specifically, languages, it is good for you to abstract out things into functions. Let's try to look at it more syntactically to understand it better. This is what the syntax of a function looks like. It starts with a function keyword, which basically means, okay, this is how you initialize a function. You declare a function. Similar to how you use var or const to declare a variable, you use function to declare a function. This is the name of the function. This is how you find the function later on. Similar to variables have names like sum, where a equal to 2, where b equal to 2. Similarly, function find sum, this is the name of the function, and these are the inputs. This is what I was talking about. When you delegate a task to your worker and you tell, or your house help, you tell them wash these dishes. These are the dishes. This is the input to your function. There is only one input right now, which is n. They're also called arguments. There could be multiple arguments to a function, need not necessarily have just a single argument. Then this is the actual logic, the actual function body, where you take the input and do something with it. Specifically here, we are finding the sum from 1 to this input that the user has sent us by using the same logic we discussed a few slides ago. And finally, we return answer from this function. So this return is another keyword you need to know of when you are dealing with functions. This at a high level is how you declare a function. Function finds sum, does a bunch of logic, and finally returns something. The logic is based on this input that is provided to the function. Let's look at another simpler function. The function is sum. It takes two arguments, a and b. And what does it return? It returns the sum of a and b. Hopefully that is clear. Feel free to pause if you'd like to pause here and read through this. Feel free to try these out as well. How to call a function. Up until now, in the last two slides, I showed you how to declare a function. When you declare a function, this body does not run. It is similar to your house help being ready to, you have hired a house help. You haven't yet given them a task. Similarly, you have declared a function. You haven't yet called the function. This is the declaration of the function body. The thing that you see below, this is how you call the function. This is how you instruct your house help ki haan bhai, please start washing the dishes. So let answer equal to find sum. This is the syntax that you will use to actually call a function. And whatever this function returns, which in this case, will be the sum from 1 to 100, gets stored in this answer variable. And then if you log the answer variable, you will have that final sum, whatever that is. Cool. This is how you usually declare functions and call them in JavaScript. Feel free to take a pause here and take a breather if need be. High level, any language you have, there will be a function declaration. There will be calling the function, and there will be storing the return value from the function in a variable. Cool. Why do we need functions is the question to ask at this point. I understand they're an abstracted place to write logic. Why? Can't I do something like this, Harkirat? Let's look at the code on the right. The code on the right does not have any functions. The code on the left does have one function called find sum. Let's first look at the code on the right. A pure code that does not use any function. I say let n equal to 100, let answer equal to 0. I iterate from 1 to n to find the sum basically from 1 to 100. Then I log it. Then I do the same thing for 1000. So I say let n2 equal to 1000, answer 2 equal to 0. I iterate from 1 to 1000, keep adding that to answer 2, and then log answer 2. I did not need to use any functions. My life seems pretty sorted. I can, write logic again and again, and I'm able to calculate. Let's say the problem statement for you was find the sum from 1 to 1000 and also find the sum from 1 to 100. You have achieved this here without using any functions. Now let's look at the code base on the left, where we're trying to achieve the same thing, but we are using functions. I define a function at the top called find sum, which does the same thing, iterates from 1 to n. And then finally, I call that function twice. Once I call this function for 100 and log it, then I call the function with 1000 as the argument and call it. Notice the difference between both of them. Both of them log this only, sum from 1 to 100, sum from 1 to 1000, sum from 1 to 100, sum from 1 to 1000. But which one do you think is cleaner? I will give you a hint. Let's say there were 5 things they asked. Sum from 1 to 100, sum from 1 to 1000, sum from 1 to 10,000, sum from 1 to million, sum from 1 to a billion. Let's say you use these two approaches. Which one do you think is a better approach? Which one do you think will have less lines of code? The answer is the thing on the left. Why? Because you are repeating yourself on the right. You are rewriting these 3 lines of code twice. You are writing the same logic again. And there is a fundamental principle in coding which says DRY, don't repeat yourself. If you are ever repeating logic, you should put them in a function and then call that function again and again rather than repeating logic, which is exactly what we do here. This is why the code on the left is better. This is why you need functions. Functions will abstract out logic inside, these 2 curly braces, and then you can just call that function again and again rather than rewriting this logic similar to how we've rewritten this logic here and here. If we would have been asked 10 questions, some from 1 to 10, 1 to 100, 1 to 1000, then I would have had to write these for loops again and again. Let's say the question suddenly changed to find the sum of all the even numbers from 1 to 100. Then I would have had to change this logic in 2 places. I would have had to add some sort of a if statement here and here if the question changed to find the sum of all the even numbers from 1 to n. But here I just have to make that change here once and I'm good to go. My find sum function will be updated for this guy as well as this guy. This is the benefit of using functions. Okay, you put all your logic in a single place rather than repeating yourself. Repeating has multiple downsides. One of them I just explained. Okay, if you ever have to make a change, you have to make that change in all the places where you've repeated your logic. Cool. That's the gist of why you need functions and the syntax of functions. Last thing I want to discuss is callback functions. Up until now, we've discussed functions. We understand their benefits. We've written for loops. We understand what are for loops. Why do we need them? Callback functions is a jarring concept, especially if this is the first time you're seeing it. At a high level, it basically is passing functions as arguments. What does that mean? That seems very jarring. Let's take a look at a smaller problem and slowly try to build intuition for callbacks. Step 1. Can you call one function inside another function? What do you think the answer is? Until now, we had declared a function and we had called it. Can you call a function inside a function? What do you think? The answer is yes. You can always call one function inside another function. Let's look at an example. Here is a function called square, which finds the square of the input, basically multiplies the number with itself. Function square, input is n, returns n into n. Then there is another function called sum of squares. What does it do? Finds the sum of the squares of both the inputs. So if there is a number a and a number b, it needs to find the square of a, square of b, add it and return it. Basically a square plus b square. How have I done it? I said const val1 equal to square of a. So this function calls the function above, and that is totally something you can do. Just how you can call a function here, you can actually call a function inside. This function can actually call another function inside, so on and so forth. You can keep calling one function from another function. This is a basic example of this. Okay, I have written this logic here once, and then sum of squares finds square of a, which is a square, square of b, which is b square, and then adds them up and returns it. If I log this on the screen, what do you think the output will be? What is square of 1? It is 1. What is square of 2? It is 4. What is 1 plus 2? It is 5. So this function seems to be working as expected. Feel free to pause here. In fact, I would urge you to write this in Replit. Let me show you how to do that. So I can go to REPL.it, sign up, click on create REPL, go to Node.js and create it. Let me write this really quick. I would urge you to write some code as well. Function square n returns n into n. Function sum of squares a comma b, const val1 equal to square of a, const val2 equal to square of b, return val1 plus val2. Const answer equal to sum of squares of, let's say, 1 comma 2, console.log answer. If I write this logic, it's the same as the thing that you saw in the slide. The answer is 5. If I say 2 plus 2, the answer should be 8 because 2 square plus 2 square is equal to 8. Alright, this looks good, Harkirat. Have you introduced callbacks yet, Harkirat? Is this a callback? No, we haven't introduced callbacks yet. This is just how JavaScript or any language works. Okay, one function can call another function. Now let's add some variation to this code. Let's say I introduce another thing here. Cube. Along with the square function, I have the cube function. Nothing too new here. Just add another function. I can add another function here to the power 4. That will, give me n into n into n into n. Now I say, okay, bhai, I need two things from you. Number one, find me the sum of squares. Number two, find me the sum of cubes. So you can be like, okay, I will describe two different functions. Sum of squares, which will take two inputs, find the squares and return val1 plus val2. Sum of cubes, that will take two inputs, find the cube of val1 and of a and b and add it up and return it. This seems straightforward. I just added another variation of both the function that takes a single input and finds the power of it, and the function that takes two inputs, does some power of it, and then finally returns val1 plus val2. Let us write this code in Replit as well. Cube gives you n into n into n, and then sum of square gives you this thing. Sum of cubes gives you this thing, and let me just log sum of cubes here, so that even though we have this square function and sum of square function, we are not using it. We are just using sum of cube, which internally is going to use this cube function. Let's run it. And we see 16. That looks right, because cube of 2 is 8. Cube of 2 again is 8, and 8 plus 8 is equal to 16. This seems to work as expected. But do you see a flaw in this approach? A flaw that's very closely related to what we discussed a few slides ago. The flaw is dry being violated here? Are we repeating ourselves when the problem statement becomes कि हाँ भाई, you have to find the sum of squares also. You can be asked to find the sum of cubes also. If you look at this logic and this logic, it is very similar. A val1 is calculated, a val2 is calculated. Of course, square gets called here and cube gets called here, but the logic looks very similar. The structure looks very similar. Function call 1, and val1 plus val2 gets returned. This looks like this is violating the dry rule. We are repeating ourselves. It would be nice if somehow I don't repeat myself here. And this is where callbacks come into the picture. Like, you can use callbacks to, solve repetition here. How? Like this. You can say, okay, bhai, there is a square, there could be a cube, there could be a to the power 4. I don't care. There could be multiple functions here. That is fine. I am going to define a single function called sum of something, sum of squares, sum of cubes, whatever. So sum of something, which will take 3 inputs now, not 2. It will take A, it will take B. These two will be numbers. But the third input it will take is the function that actually needs to run under the hood. This could be the square function, this could be the cube function, this could be something else. And I'm going to be like const val1 equal to fn, which is this input right here of A, const val2 equal to fn of B, and return val1 plus val2. Notice, okay, the thing that I said in the last slide is being repeated. I put them together. These were repeated, but there was one small difference between them. It was square was here, cube was here. I said, I am going to accept that as a third argument, and I will call whatever the end user wants me to call. If the end user says find sum of something a, b, and square, then square is what gets called here. If the end user says sum of something a, b, cube, then cube is what gets called here. I will not need to write 10 different aggregation functions. I will just write a single function. Whoever is calling me, please tell me, what do you want? Do you want sum of squares? Do you want sum of cubes? This is what's called a callback function. Specifically, the third argument that you're sending here is called a callback function, because one function is calling back the other function. This is technically not very true, but for now, best definition of a callback function would be when you can pass one function, which in this case is square, to another function, which is sum of something. That's what's called a callback function. It's basically functional arguments. Your argument can be a number, your argument can be a string, your argument can also be another function. And specifically, why is this useful here? This is useful because this ugly code that I wrote, if I had cubes and to the power 4 and to the power 5 here, rather than describing 5 different aggregation functions, I describe a single one. And I say, bro, whoever wants to, what is this guy's purpose? What was this guy's purpose here? It was using the other thing as a black box. Its purpose was, find the squares and then sum it up. Find the cubes and then sum it up. So this guy says, bro, I have a job of, finding either a square or a cube or something and then summing it up. I have that logic, but you tell me what you want. You want a square or a cube, and I will do that specific thing. That is what sort of the only jarring thing here. That's the only jarring thing here, which is how can you actually pass a function as an argument? But the answer is you can. In JavaScript, the argument can be a string, a number, a boolean, or a function in itself. And whatever the function body is inside, it can actually call this function and actually get the value from it and then do whatever it wants with that value. Let's see this in action. I have sum of squares, I have sum of cube. I'm going to remove this one. I'm going to call the first one sum of something and add a third argument here called fn. You can call it anything. Most of the times this is called callback or CB. So let me just call it callback. And I'm going to replace both of these with callback. Lastly, when I'm calling this, I'm going to call it with 2, and maybe sum, which is, square, which is this function right here. What do you think the output should be? If I'm calling sum of something with 2, and square, what will the output be? It is 8, because 2 to the power 2 plus 2 to the power 2 is 8. I can actually log callback here. So you can actually see what callback looks like. I can log A as well, right? I can log A. And I will see 2 here. I can log B. I will see 2 here. I can log callback as well. Let's see what it returns. It says 2, which is A. It says function square, which means square was passed in here. That is what is present here. I can actually call it and do whatever I want with it. Similarly, I can also pass in cube here. And if you look at the logs, it says 2 followed by function cube, which means this callback is a function in itself. And I'm calling it here and here, finding the values and adding them up. Cool. That is what a callback function is. Hopefully it's slightly clearer now. I would urge you to solve this problem, put a few logs and try to figure this out yourself as well. Cool. Last thing I want to discuss is something called anonymous functions, which basically, who is anonymous in the real world? Someone who doesn't have a name. So what is an anonymous function? A function that does not have a name. Harkirat, if a function does not have a name, how do you call it? Great question, sir. The answer is, for a use case like this, where we are just using cube or square as arguments, I can, rather than defining it separately and giving the name here, I can simply put this whole body here as the third argument. What did I do? I said, bro, first 2 arguments were the numbers only. Third argument was a function. I could either do this, third argument is a function, or I can literally define the function here. Copy. I literally copied the function body, pasted it here. This is still a function. This will still work. But do you really need to name this function? Will you ever be able to even call this function from outside? The answer is no. Which is why whenever you're passing it a function directly, natively to another function like this, you don't name it. You simply pass it. You say function, argument, and then the final function. Cool. And again, when the control reaches here, so let's run this and see what happens. It says 2 function anonymous and then 16. What does anonymous mean? This function doesn't have a name. Can I put a name here? You can totally put a name. I can say function square. Should you? Probably not, because this cannot really be used anywhere. I can't really call like this square from outside for a few reasons of scoping, which we can discuss later. But at high level, if you're passing a function as an argument like this, then always make it an anonymous function. Cool. That's all I wanted to cover. I think that's the last slide. Hopefully we learned about loops that a few people weren't clear about. I'm hoping most were. Functions, which are also easy, but callbacks is the most difficult thing, much needed before next week. So hopefully you understand it. Would urge you to Google after this and find more resources if you still don't understand callbacks well. Cool. With that, that's it. I'll see you guys in the next one. Bye bye.